Question 8, we've been asked to transform these two trig functions into a single trig function using the harmonic form process. Let's get that out of the way first and then find out what they're on about, because this is a very standard routine that we need to employ here. First of all, we've got to start by expanding this expression using the compound angle formula. R cos theta minus alpha turns into this expression, a pair of cos terms and a pair of sine terms, both multiplied by r. If we now compare that with the expression we've been given, we can see, therefore, that r cos alpha must equal 2 and r sine alpha must equal 8, equation 1 and equation 2. If I divide equation 2 by equation 1, sine divided by cos will equal tan, and the r's will cancel. So therefore I can say that tan alpha is equal to 4. Now to get r, we've got to square both the equations and add them up. I get that r squared cos squared alpha plus sine squared alpha is equal to 2 squared plus 8 squared. Cos squared alpha plus sine squared alpha is equal to 1, so therefore I get that r is equal to the square root of 2 squared plus 8 squared. And this turns out to be 2 root 17. They need alpha in radians, and if you look that up on a calculator and quote it to 3 decimal places, you get that alpha is equal to 1.326. And that's to 3 significant figures. And those are the 2 answers for part A. So let's have a look at part B. Part B says that there is an arithmetic sequence, cos x plus sin x, cos x plus 2 sin x, and it goes on. And we're told that S9 represents the sum of the first 9 terms of the series. And we're asked to find the maximum value of S9. So what does S9 consist of? Well, if cos x is in all 9 terms, we must have 9 cos x. Now, sin x will clock up to 8 sin x in the 9th term. So this will be 8 factorial sin x. And 8 factorial equals 36. So we've got 9 cos x plus 36 sin x. And if we compare this with our original equation in the question, we can say that this equation is our old equation multiplied by 4.5. Now in part A, we equated our old equation with an r cos theta equation, and we got that it was 2 root 17 cos theta minus alpha. I'll still use alpha because yes, I know alpha is 1.326, but it's simpler to write just alpha. So to equate both sides of the equation, I have to multiply this side by 4.5. Now the cosine part of this waveform can only reach a maximum of 1. Doesn't matter what theta or alpha are, this can only get up to 1. So our maximum value is 9 root 17. And that's the answer to part 1 of B. Now part 2. Just to say that alpha will be the same because we've multiplied the ratio 2 and 8 by 4.5 each, so it's a factor that will cancel out. So what applied before, tan alpha being equal to 4, still applies with this new setup. So I can use the same value of alpha in part 2. We've been asked to deduce the smallest positive value of x, yes, we're in x rather than theta now, at which this maximum occurs. Well, it occurs when cos theta minus alpha equals 1. Yes, I'm still using theta. I know the new sequence has got an x in it, but that shouldn't matter. That shouldn't throw us. When does a cosine equal 1? Well, it is when the angle equals 0. So therefore, max occurs at theta minus alpha is equal to 0. So therefore, theta equals alpha, and alpha equals our value that we got in part A, which is 1.326 radians to three significant figures. And that is the answer.